Kevät.
So good evening, all of you. I'm so happy that we have this kind of a dark evening. We have so many people here and smiling still. It's really nice. So welcome all. I'm Arja-Liisa Kaasinen and I work here in the museum as the head of collaboration and engagement. And I'm really happy about this collaboration, this Woodworks events. This area of events is a collaboration between Aalto University, thank you Pekka Heikkinen, and also the Ministry of Environment. Petri Heino is also here, thank you. If you want to talk more about this program and these another event, so Petri and Pekka will be here after these speeches, of course, if you want to talk or give some feedback or ideas how to continue this area. So this area is curated by Pekka Heikkinen, and Pekka is going to introduce you the speakers of this evening. The theme today is reuse and repair, and all these events have been related somehow to wood as a material or some kind of a new ideas of planning to use wood as a material or the basics of the work or planning work. So Mark Hughes and Satu Huuka are going to speak to this evening, but Pekka, I will give now you to the floor so you can tell a little bit more what's coming also during this autumn. This area is going to continue this during this autumn. So warmly welcome. Have a really nice evening today. Welcome, Pekka.
So thank you for coming. We have two more sessions which are quite soon. Next one will be next Monday at 11th. And then we have two visitors from the other one, all from Canada. Michael Green, which you might know, a guy who dreams about 30-floor wooden house and does big mass timber buildings. And Mikko Vilekainen, who is the head of the Finnish Wood Council, they will discuss that how could we spread the wood construction more wider. And the last one, we have a our own member of parliament, Anders Adlercreutz, colleague of mine, who with Pekka Pakkanen talks about the future that architects and what is the architect's role in the future challenges that we have. But today we'll talk about reuse, a little bit about repair as well. And although we didn't agree, Mark Hughes, my colleague from Aalto, whom I, by the way, haven't heard about talking about this issue, so I'm interested to hear it, although we have a quite close cooperation, so maybe we should discuss more in Aalto as well. Anyway, you somehow read my thought, because this is exactly what we are talking about here. Of course, the role of the wood in the future building, and if you haven't heard about circular economy, you haven't read any papers lately, which will be anyway turn from linear to circular economy. Of course, it's coming, and we may not know yet how to react on that. And that's why I asked both Mark Hughes and Satu Huhka to talk about that, to give us a little bit advice from the coming challenges. I was surprised when I looked at the statistics that more than half of the timber goes to renovation. But on the other, you don't see it anywhere. It seems that not all, but quite many wooden houses seem to be torn down and the material goes somewhere. And then the timber, 50%. Timber, by the way, is one of the three biggest building materials. More than 1/3 of the markets is covered by timber. I guess it's about roughly like that. So where does it really go? Then on the other hand, I think it's a little bit kind of interesting and confusing times that, for example, the Minister of Environment thinks about on European level that when we in the future have a need to have new facilities, we have to look first that is there any existing buildings that could be used? And if you don't find any, then you can build a new building. And I think that will challenge us as well in the future. Hopefully I didn't put you too big challenge to kind of clear the situation, which I'm at least very confused, but let's see whether we are more clever after this or more confused. But welcome, Mark Hughes, and the floor is yours.
Thank you, Pekka, and good evening. I hope you can hear me okay. I've got a bit of a head cold, so if I sound as though I've got cotton wool somewhere in my head, it's probably because I have. I would like to share some of the work that we're doing currently and have been doing now for, I guess, 6, 7, 8 years now at Aalto, looking at the issue of not just circular economy. When we started thinking about it, we didn't really think of it in terms of circular economy. It was more about resource efficiency. I think the term circular economy hadn't really been coined at that point to any great extent, and it's only in the last, I guess, 5 years or so that really it's taken off as a concept. A little bit like sustainable growth, I think circular economy is a little bit of a slightly oxymoronic in the sense that I don't believe you can have sustainable growth, and I don't believe you can have a truly sustainable economy either. I mean, there's always going to be losses in the system, but that's another point, and maybe come on to that a little bit later on in the presentation. I have to confess to being very nervous because I've never spoken in front of a crowd of so many architects. So I'm a mechanical engineer by background. I've found my way into wood about 25 years ago. So a lot of the concepts when it comes to the use of wood in buildings, I would have to say I'm not really that familiar with. So you can please shout me down, maybe not shout, but maybe just point out where I go wrong, by all means. I'd like to talk a little bit about some of the programs that we are dealing with. Okay. So, I mean, no surprises here. I think everybody is fully aware of the impact of buildings and construction. Approximately half of all materials that are extracted go into construction, into materials. And was it only last week? I was looking or seeing some figures presented where the expectations for the extraction of materials are set to increase still phenomenally. So it makes you wonder, given what's been happening over the past 6 months or so in terms of climate change and so on and so forth, how we can continue this trend. It's clearly not possible. Around a third of all emissions, CO2 emissions, are related to the production of energy and materials in relation to buildings, and around 40% of energy consumption. So whichever way we look at it, I mean, there's a fairly huge impact. But also, what makes me kind of a little bit motivated about this is that there's also a huge potential to make an impact. So if we do something, if we make some changes, we can actually have some fairly significant changes to the overall situation in terms of resource consumption and emissions. So that's something that I think we have to take as a positive. Maybe you can tell from the accent, I'm not from Finland, I'm from the UK. We don't have a great tradition for wood construction there. Finland does have a great tradition for using wood, maybe not in all sectors, and we could actually do a lot to improve that. Maybe I'll come on and touch about that a bit later. But why the interest in wood? And I think from the sustainability perspective, then one of the key aspects is that when we're using wood as a structural material, we're replacing another material, usually concrete or steel. And the advantages to that is that when we're using wood, well, you can saw wood by hand. When you come to work with metals, you can saw it by hand, but it's an awful lot more work. There's a lot of energy required in order to manufacture and to process steels and concrete. So there's a lot more embodied energy. So that has a lot of carbon implications, carbon emission implications. So when we use wood, we can substitute for these other materials, and that has a very positive effect. The other thing is that wood is made from carbon dioxide, water, some sunlight, and some other compounds. And approximately half of the mass of a piece of wood is carbon. And of that, if we think about when we're creating a piece of wood, we require about 1 3/4 kilograms of carbon dioxide is required in order to make 1 kilogram of wood. So for every kilo of wood, we're saving, if you like, storing away approximately 1 3/4 kilograms of carbon dioxide. So we can think about wood in long-term applications as a long-term carbon store. For sure, when the wood is destroyed, it's burned, or it biodegrades, then that carbon is then re-emitted back to the atmosphere. But if it's in place in a building or an artifact for 10 years, 20 years, 30 years, a century, 2 centuries, 1,000 years, then that carbon dioxide has been retained, it's been kept away from going back into the atmosphere for that length of time. So there's a positive carbon storage benefit and story to be told from utilizing wood. And an aspect, I'm going to talk about these first 2 points tonight. I'm not going to talk about the other aspects, which Pekka has heard me talk about many, many times. Probably is very sick and tired of hearing about it. But also then there are energy benefits because wood has very interesting material characteristics. It's a good thermal insulator. It's visually very appealing. I mean, it has good tactile properties, and all these kind of features make wood a rather nice material to live with. And also we could utilize it to even passively control the interior environments of buildings and of rooms, living spaces, and that can lead to some good health benefits and certainly benefits in terms of levels of comfort and well-being. And I think that's something that, well, certainly at Aalto, I've been talking quite a lot to many of our architect colleagues, and I think that's a very positive story to tell. Okay. But I think I think that nobody really disagrees with the fact that there's a great potential to increase the climate change or the sustainability, if you like, of construction by utilising more wood. So on the right, the left-hand side, I should say, we certainly need some kinds of mechanisms or incentives in order to promote the use of wood in construction. It's not happening at a rate. I mean, in certain areas, residential buildings, for example, yes, it's well established. But in other areas, multi-story buildings, for example, there's a lot that could still be done in order to promote and to roll out the utilization of wood. Well, we are faced with some possible problems in the long run, namely the supply shortages. We know that we have a big forest resource here in Finland with something like about 100 million cubic meters of wood growing annually, of which we cut and utilize something like 60 million cubic meters annually. You would think that there's a potential to increase the amount of wood going into wood products of all sorts, not just wood construction, but also of paper products and chemicals and fibers and things like that. But there comes a point where we can't take more out of the forest without seriously having to think about the loss in biodiversity and the other ecosystem services. And if we think about climate change and maximising the climate change potential of utilising wood, we need to think about the resource. And I think all too often we don't think enough about the resource base. Where does wood actually come from, and what are the implications of utilising wood? So we need to have this in mind. And there's been studies done to say that, well, yeah, okay, within the next 10 or 20 years, we're going to run into some problems when it comes to the sustainable supply of wood fibre. So the question really arises then, what can we do? How could we, on the one hand, how can we maximise the storage of carbon in wooden buildings? How can we maximise the benefits of substituting other materials? Without then compromising the ability of forests to sequester carbon from the atmosphere, act as a sink, and also to retain the biodiversity and other ecosystem services. So that's a big question, I think, that we have to kind of grapple with. And this really, I think, requires a slightly different approach to our thinking. We need to think at a very much a systems level. We can't think of things in isolation. We can't just think about only the wood value chain. We can't think about only the construction. We can't think only about forestry. We need to include all the various actors and stakeholders in this system to create a compromise and an optimized system that maximizes the potential of wood, both in the forest and in the built environment, to store and mitigate climate change, store carbon and mitigate climate change. So we need to think about it in this kind of systemic way. And this is something we're now starting to approach the problem from this systemic perspective, rather than looking at kind of single issues. So I was talking moments ago about resource efficiency. That's where, or materials efficiency, which is where we really started this discussion about. And of course, we can think about efficiency in different ways. When we think about the application to the wood value chain, we could think about the efficient utilization of the raw material. This is something that the forest industries are very good at. So a unit of biomass, a log, can be broken down into sawn timber, it can be broken down into chips that can be used as a feedstock for making various polymers or fibers, paper products, a whole range of different things. What's left over can be used in other material applications or to produce energy. So it's an efficient way of utilizing materials already. There's a couple of examples here. Aalto has done a lot of work looking at producing, for example, alternative fibers to cotton and other fossil-based fibers for textiles. But these are based then on forest resources. So there are many ways in which we can increase the efficient utilization of biomass. Another way we can look at efficiency is also through the longevity of products. So everybody says we live in a throwaway, disposable society, and I think that's true. In my, I would say short lifetime, but in my lifetime, I think we've got away from repairing things to just throwing things away. It's crazy, utterly crazy. And there are plenty of examples of old buildings that have been around for at least centuries, maybe 10 times over. So by having an extended use time, then that has the benefit of storing the carbon for a long time and also being very efficient with the use of the raw material. The other thing that we're certainly not very good at doing is thinking about what do we do after the use of wood. So when it comes to wood that has been torn down from buildings, removed from buildings, we are usually ending up with a pile of often broken bits of wood, which are then difficult to reuse. We don't really think about the reuse. We don't actually think about reuse much in products full stop. So most products are made without really any thought whatsoever to how we recover the materials. And some of these are very, very valuable materials. Certainly that's the case in wood. The picture on the right here, the bottom right picture is actually a picture that was done by a student group maybe 6 or 7 years ago. They decided they wanted to look at this idea of cascading. How could they actually produce something from waste wood? And they came up with this idea for a coffee table. I mean, it was rather nice. It worked very well and demonstrated that you can actually do something with just broken bits of wood. Will you excuse me a second? I must take a glass of water. Okay, so we produced in 2016, so the statistics from the EU and FAO, about 884 million cubic meters of sawn wood and wood-based panels. To put that into some context, that's a cube of wood product, approximately a kilometre tall. And as your architects, you'd be interested to know you could put the Eiffel Tower 3 times on top of each other in that box. So it's a large amount of wood products that are being manufactured on a yearly basis. Of course, not all of these go into construction, but a large proportion do. So there's a lot of wood material actually going into buildings on a regular basis, and of course other products. But they're going into buildings on another basis. That is instead the equivalent to about 750 million tons of carbon dioxide. So that wood that was manufactured, removed from the forest, you could argue that removing it from the forest, you're creating an environmental problem, but in the sense that you are retaining the wood in solid form, in material form, and placing it into a building, you are storing the carbon there and you are substituting other materials that would otherwise be used if you weren't using wood. So we can think of the built environment of buildings as a little bit like an analogous situation to the forest. It's a kind of a resource, it's a store of materials. So it's a kind of an urban forest, if you like. How much is actually available? Well, we've been involved in a few studies, and actually from a a study that was conducted from a European project in which we were involved, which finished a couple of years ago. Approximately 32 million cubic meters of solid wood is present in residential buildings in Austria alone. We've actually I haven't put anything on the slides here because I've only just had the thesis, but I've had a student working with me now for the past 6 months, and she's been looking into the potential amounts of wood here in Finland in residential buildings, and the value that she came up with was 17.1 million cubic meters. So there's a lot of wood actually embedded in the buildings, in the building stock at the present time. 17.1 million cubic meters is a very significant amount of material. So why don't we use it? Why don't we actually make use of this? And the prediction here for Austria, and I think when we look into it, we'll probably find the same will happen here in Finland, is there's an expectation that that amount of material will increase, and so there'll be an increasing amount of material available to be utilized in the future. So one of the concepts we've been working with, and I'm sure Satu will also be talking about this, is about resource cascading. So the idea here, the concept here, is actually to, rather than to lose the quality or the value of a material simply by disposing of it, then you retain the value or the quality by reusing it either in other identical applications or in other applications that have a high quality requirement. So rather than, for example, using a piece of sawn timber and then just chipping it up and putting it in the fire, you retain it in the solid wood form to make another maybe load-bearing element or another interior panel or whatever it might be. It retains the quality, a higher level of quality for a longer period of time. And you can repeat this in a cascade until eventually, by the time you've reprocessed it several times, then the quality has been lost and there's not much else you can do with it. But you have had a lot of utility, a lot of use out of that material throughout that time. So this is the concept of cascading, and I've got a pointer here, but here conventional use is what we do currently mostly is we have a material, we use it once or twice or whatever it is, and then throw it away. The idea with the cascading is that we extend the period of time so the quality is retained for longer. So if you think about carbon storage, we retain more carbon for a longer period of time, therefore we have a more efficient use of material.
Could you not tell an example of product that could be extended, the service life could be extended like that?
You've preempted my next slide. You're always doing that. I know. So this is an example of a wood cascade. So we might start out with for example, solid wood. And then there could be subsequent solid wood products. It might be from a large beam. It has to be reprocessed slightly to make a smaller beam. And then once the beam has has lived its useful life, it then has to be converted into particles, and that could be used to produce particle board. After that, when the particle board has maybe been in a piece of kitchen furniture or bathroom furniture, it's reprocessed again to create fibers. The fibers can be used in some fiber-based product, maybe some form of packaging, and then even the fibers could be recovered and then reprocessed, could be chemically processed into chemicals or into textile fibers, and eventually then reclaimed and used for energy production. So providing we don't lose material through the system, that material will always be available for energy production. It's just that we've made more use of it in intermediate products throughout that period of time. But this is the situation currently. This is what we tend to do, is we take solid wood and it up and chip it and then produce energy. And that's not a bad thing necessarily, because although we could make more use of it, we have to also consider what other inputs we would need to make to create these other cascaded products. And if the inputs exceed the benefits that we would actually gain from doing that, then it doesn't necessarily make sense. Maybe to give an example, maybe an extreme example, if we had lots of fibers, we wouldn't want to try to stick them all back together to make a solid piece of timber. That just wouldn't make any sense. You have too many inputs. So there comes a point where it becomes difficult. That's why I mentioned my little bit of skepticism about circular economy, because we can only recover a proportion. We can never really recover 100% of the materials. There will always be losses of some sort or another. But what we could strive to do is to create a step in here, for example, through the production of particle board. We don't do that here in Finland because we don't have a large particle board manufacturing base, but in many parts of Europe, Central and Western Europe, then there are particle board manufacturers who do already utilize quite significant quantities of recovered material, not from buildings, but from things like pallet wood because of the cleanliness of the material. So many particle board products are already incorporating maybe 70–80% of recovered wood in their production. And that particle board is then available for the production of energy at the end of the day. What we would like to see really is actually another step where, first of all, the recovered wood would be utilized in a solid wood form before being converted into particle board and eventually burned. We may be able to put another couple of steps in there as well, but I think realistically, if we could go from solid wood to another solid wood application and then to particle board and then finally for energy recovery, we would still have an important positive contribution to make. So in short, what we're trying to achieve is, I think everybody's familiar with the terms of reuse, reprocess, recycle, recover, reduce, reuse, recycle. It's well known. So if we could reuse components from buildings, either in the existing form or in slightly modified form, that would be an ideal situation. If we can't do that, if we could do minimal reprocessing to enable the material to be reutilized in solid wood form, that would be great. If we can't do that, there'll be fractions that we can't recover in solid wood form. We could then recycle that into particle board, or we could use it finally for energy recovery. So we're trying to ideally create more circularity into the system. So what's the problem? Why don't we just do it? Well, this tends to be the issue. Go to a demolition or waste management company, we tend to see lots of bits of broken wood. And it is usually lots of bits of broken wood, looking rather similar to this kind of picture. We have wood that's mixed with other materials, it's coated, it's in the form of systems, part of a wall system. There are often adhesives or insulation materials, certainly lots of metallic components to joints and things like that. These all make it rather difficult, and during the demolition process then the only relatively quick way to do it is to smash it with a grab effectively, and that breaks up the wood. So a lot of the intrinsic quality of the wood is actually lost in the demolition process. And these are some examples of the type of... It's a piece of art. Yeah, actually, yeah, I was going to say, I thought it's the right form, isn't it? Piece of art. These are actually taken from our exhibition in Aalto. So, but this is quite typical. You see a lot of nails protruding. Actually, I recovered some of this personally, and last weekend spent quite a few hours removing the nails so I could reprocess it. Other things you see in addition to nails and those kind of things is you see plastics, polymers, insulation materials, sort of polyurethane foam here. It looks like Styrox, so all sorts of different things that are adhering, which make it difficult to clean it. And the other thing that's perhaps more problematic are the chemical coatings and preservative treatments that are often rather difficult to actually identify. So that's one of the problems with the practical recycling of wood. So I'm going to mention one of the projects. I'm going to mention a couple more projects. I'm very pleased that Petri is here because this is actually funded by Petri's program. The Circwood project. What we're trying to do is to really to understand, well, if we were to recirculate, if we were to recover wood in a form that made it more suitable for cascading, what would be the implications in terms of the sustainability? So what we're trying to do is we're looking at kind of hypothetical scenarios where, okay, what if we were a little bit more careful with our dismantling of the buildings? We use some kind of smart demolition practices to recover the wood in a better state. What effect would that actually have? Another thing would be, and I'm going to talk about this because I think this is an important point to make, is design for disassembly. What about if all the buildings that you build and design from here on in are built so that it can be fully dismantled? So you recover all the materials. That's a challenge to you as architects. If we could do that, what would be the impact? If we could recover the wood materials from those buildings and we could reutilize them in different products. We could either use them in new buildings, different buildings. If it's not into buildings, what about into furniture? What about into other such things? So what effect would this then have on the sustainability? So we're trying to model that, trying to understand what the impacts would be. It's challenging because it's difficult to assess what the current practices are because they vary quite a lot. And what would smart demolition practices actually look like? And as for design for disassembly, well, we've really got very little clue about what that would mean in reality. So the idea would be that we would see what would happen if we could shift the emphasis from this end of the spectrum more to the reuse and the reprocessing end of the spectrum by the introduction of a design for disassembly paradigm. So I think I probably stated this already, but of course current demolition practices aren't really compatible with material recovery. They're compatible with quickly demolishing the building so that it can be moved on to the next phase, which is usually or often rebuilding another building on the same site. So we have another project that we are now working on. We're actually we're entering the third phase of this other project called Rewood. So I'm not very imaginative with names for projects. And actually this is Rewood 3 we're on now. This is Rewood 2, and we had a Rewood 1. So not very, very imaginative. I'm an engineer, so that's my excuse. But what would happen if we could actually design buildings that could be disassembled, or maybe not disassembled? We're not talking about disassemblable buildings. We're talking about buildings that can be, that we can recover the materials and they can be reused. Not a modular building that is rebuilt somewhere else, but a building that is we can recover the materials and reutilize those materials. So we're now working on putting together a project where we will actually build a building, and I am working with architects on this. We will build a building that will then be dismantled, and the materials will be given as a starting point to a new set of architects who will then build another building from those materials. It won't be the same building, but something else. And we will learn that process. That's our aim, is that we will learn by it, because we don't know how to do it. And we need to learn by the experience. So this is something that we are now working on. We have a concept. We've just had a workshop a couple of weeks ago, a workshop actually to do to scope out what this building will be and what it might look like. So I'm going to actually close now. I'm just going to mention the projects that we've got running, because they might be kind of make some kind of connections here. We have a project called the GoWood project. This is funded by Climate Kick. Some may be familiar with the EITs, the European Institute of Technology, KIC's Knowledge and Innovation Communities. We have a project where we're actually working in conjunction with, again, the Ministry of Environment, Citra, UNFCCC, to look at digital technologies and the use of digital technologies to account for the carbon. If we could, the reasoning here is that if we can say with some precision what the carbon content of this building is, and if we make decisions about the building choices, design, what implications that would then have on the carbon content, then that would help us create incentive mechanisms that would help support the utilization of wood and roll out the use of wood construction. We have another project, again funded by Climate Kick, where we're working with partners in Sweden and Switzerland to look at developing a tool that would allow stakeholders, designers, architects, decision makers to make decisions about the materials that they use in buildings to enable them to select what the most sustainable choice would be. Often we believe it would be wood. It might not always be, but it would allow them to make a kind of an informed decision about the sustainability of the building. Circuit I've just mentioned. I won't talk about that. And we have another project in Futurewood, which is now, this is a European. We're looking at the resource base of materials in Europe, wooden resources in Europe, and how we can harness these to create new buildings. Looking at design for disassembly as a means to enhance the recoverability of the wood materials, and then the ReWood I've mentioned. Lots of acronyms, not very, very imaginative. All have got wood in them, haven't they? Yeah, okay. So anyway, so those are the projects that we're working on at the moment. I mean, if there's an invitation at a future point, I would be happy to come back and tell you more about these projects as they continue. So I think I'm more or less out of time. I managed to 27 slides or 25 slides last quite a long time already. Just some final thoughts, or maybe aspirations, if you like. I think it's certainly important as we go forward that we need to adopt systems thinking. We need to involve all stakeholders. And I'm an engineer, I'm a scientist. I'm used to being in a laboratory by myself or with a few colleagues, not really thinking too much outside that realm. But it becomes increasingly important that we involve all stakeholders in this process, because I think there is always the danger that, okay, wow, yeah, let's all make wooden buildings, and then suddenly we find, oh, we've run out of forest. That's not really a very good situation to be in. About this kind of materiality of products, then thinking of buildings as material stores. I know this is already changing, and there are very good examples of projects that are looking at materials as buildings as material banks. I think this is something that maybe we need to think more about. How can we just consider that, yes, okay, it's somewhere that we have as a space to live or work or whatever, but also how can we think about the materials that actually go into the construction to retain those and to give them value. I think materials need to be given value. Why do we tear down buildings so quickly? I mean, I was talking with a colleague of mine from the UK, and he told me that the average lifespan of a commercial building in London is 15 years. That's utterly crazy. I mean, I just don't understand it. I don't know enough about the building process and architecture to understand the phases that a building will go through during its lifetime. I think that's something that's really interesting to see. Maybe when we're talking about design for disassembly, we should be also thinking about design for adaptation, so that buildings can be more adapted to suit new purposes. And certainly we should be thinking too about designing buildings where we can recover the majority of the materials. And I have to admit that I think we think about a lot of products we use that go into buildings. They're actually quite complex. It makes it very challenging to recover the materials in the first place. So we maybe need to go back also to the point of the manufacture of the products, to think about how they could be produced in a way that would make the recovery of the materials much more, much easier. Very happy if anybody would like to make contact. Really happy to talk more about this. I'm always looking to engage, particularly with architects, to get their opinions. A lot of what you might think what I've said is a load of rubbish. I don't know, but we certainly need to understand this in the kind of the idea of working with stakeholders. We need to work with stakeholders to try to understand what the issues are, what would help to promote the utilisation of wood, and also then this additional part of the circularity, the resource efficiency with wood construction. So, with that, thank you.
Thank you, Mark. Nice that you kind of presented yourself at the end, because I forgot to do it. So, professor in wood technology in Aalto. Do you have a quick question while Satu Huuhka, our colleague from Tampere University, will fix the presentation, and Satu is part of the building environment in transition research group and a few more, docent in Tampere and researcher as well. Satu finished her doctoral thesis or degree in about 3-4 years ago. Do I remember right? And the issue was the what to do with the building stock roughly. And I guess you will tell a little bit about your things that you have done with your students, the kind of studying the things that Mark explained, that how do we turn scrap to usable products, which doesn't sound too easy. But is there any quick questions for Mark before Satu starts, or do we share the questions at the end? Or
I have another microphone here if someone likes to ask anything, but we're streaming live, so if someone is too shy to ask at this point, your face will not be shown, but your voice will be heard all over the internet. All the better. But we can take the questions at the end of the event as well, unless there's something at this very moment. Anyone?
maybe we'll hear Satu and then discuss more about that.
Thank you, and thank you, Mark. It's really nice to continue from here, because I think we have some overlaps in our presentations, but overall it's a good point for me to start. So I'm going to talk to you about tectonic use of reclaimed timber and how to turn scrap into architecture. So like we heard in Mark's presentation and like we've heard in the media, and elsewhere, timber has been proposed as one solution to climate change mitigation in the construction sector. And it is, but disposing or recycling timber can be more complicated than recycling concrete or recycling steel. We're not supposed to landfill timber, and if you burn the timber, it's not really recycling. Even though the energy production can be useful, it is not recycling. And here in Finland, because of the way we've built in the past and still do, the majority of buildings that are demolished are timber buildings. They are generally very small buildings, so even though they make the majority in numbers, in terms of the material that originates from them, about 1/3 of the demolition waste is assessed to be wood, maybe a bit less. But it seems that wood might be the largest waste stream, together with concrete, as large as concrete waste. As Mark informed us, if we reuse or recycle timber, we can lengthen the time that the carbon stays stored in the material. You didn't show this image, though. I think everyone knows from Ellen MacArthur Foundation, this is a redrawn version by my colleague. So here we have the idea of the circular economy system where we have the biological cycle on one side and the technical cycle on the other side. And it's here on the technical cycle that we have these reuse and refurbish and recycling loops, whereas the biological cycle is a bit more simplified. So now you can think that, okay, great, wood is biological, so it can enter this cycle quite easily. And were we to build like we did in the old days, that would be true. So in the archaic way, where almost all of the material in the building was wood. But the way we build today, that's not exactly true anymore. The way we use wood in buildings, it's engineered wood. So it doesn't automatically enter the biological cycle. Like Mark mentioned, it has glue, it has paint, it has other substances that actually prevent it from entering the biological cycle. So we should actually treat it as a technical material rather than a biological one in terms of the circular economy system. This is basically the same image that Mark already showed you, the stages in which you should proceed. So you should start always by preventing the creation of more waste, and then reuse, recycle, and utilize in other ways. So this is basically the same as the cascading cycle. If we translate that to buildings like Mark did, we have here what he mentioned in the case of new buildings, designed for deconstruction, but even more importantly, what he also mentioned, the service life extension. Every year, the amount of new buildings is only 1% of the existing stock. So whenever we are talking about component reuse or material recycling, we're actually dealing with that 1%. So it's more important to work with the existing stock to extend the service life, because that's where you can achieve most impacts. However, I'm not going to talk too much about that today, because I'm also talking about reuse and maybe bringing it a bit closer to construction. So I'm afraid Pekka will have to arrange another lecture for the repair point of view. In the EU, we have a target that we should be able to utilize 70% of the construction waste as material. And that would mean reusing, recycling, or also some landscaping actions can be considered to belong to those categories. And here, wood is a little bit problematic, because what we do is that we incinerate it to create energy. So we should find a way that we could also increase the level of quality in the wood utilization. If we compare it to the other materials, such as concrete or steel, here you can see what different options we currently have for reusing, recycling, or other utilization. And as you can see, we don't really have that many options here. And one of maybe the problems with wood is that if to recycle wood, all we can do is make fiberboard. Of course, there's always room for innovation. But if all we can do is fiberboard, well, you can't build structural frames out of fiberboard. So to build structures, actually, reuse is currently the only option, the only feasible option that we have. I hope there will be some innovation there as well, because here could be some other options in terms of, for example, massive wood products. This is maybe a more practical image regarding the cascading of wood from Mark's student, I believe, Daishi Sakaguchi, showing these steps of the cascading. And here he has suggested that some glued laminated products could also belong to the cascading chain, but unfortunately that's not available at the moment. So it interests me as a researcher what we could do here in the first steps of this process. A large part of my research has focused on the properties of demolished buildings, because I wanted to understand the properties of these materials and also the properties of the buildings that are being demolished, and maybe to think about how we could avoid that demolition in the first place. But if we take, nevertheless, the viewpoint of the material, looking at the buildings that are being demolished at the moment, we can say that these are the two basic types that are the most common. The wood waste comes from these small buildings, which are either the traditional log buildings or the post-war reconstruction era buildings with balloon frames. And the challenge is, like Mark said, that when the material comes from the demolition site, it doesn't look like this. I have the same image as you did, almost the same. It looks like this. And the reason is the way we demolish at the moment. It would be possible if we use different kinds of demolition methods to get more value out of the demolished material. Your Mark student, Daishi Sakaguchi, also made a field study where he followed the demolition project of a daycare center, and he recorded what happened to the material, or rather to the length of the timber components in that process. And yet, like you can see here, there are some cross-sections of timber which retain their length quite well, like the smallest one and the largest one. But the cross-sections in the middle, there was actually a really drastic loss of length as a result of the demolition. So if we wanted to avoid that, we should employ deconstruction practices that would be more labor-intensive and use less machinery than the ones that we currently use. That way, it would be possible to bring the recovered material closer to the virgin material in terms of its properties. In the studies regarding the reuse of timber, it's actually us architects that have been attributed with this possibility to increase the demand and the supply for reclaimed timber. And even if we use the best deconstruction practices that there are still challenges because if you use reclaimed components, it might be quite difficult for you to procure them. Where do you find the material that you're looking for? The quantity and the quality is inconsistent, the dimensions may be inconsistent, and they may be incompatible with current modular grids, let's say, and you might have to do a lot of redesign to overcome this problem. So one of my key points is actually that the reclaimed timber is not the same material as the virgin timber. We should think of it as a completely new material in order to increase its use. And this is where we get into tectonics. I don't know if you're familiar with this term. Would you maybe raise your hand if you are? Okay, not too many, some, yeah? So I have a couple of quotes here to introduce you to tectonics. It's one of my favorite theories of architecture. I'm a sucker for it. Ole Egholm Pedersen has said that structures are tectonic when the material and technique have a significant impact on the initial idea about form in such a way that the final structure can be said to be a consequence of the material and technique. Other way to put it is what Juhani Pallasmaa said: tectonic form derives from properties of materials, structural logic, and the crafts of making. Or the way Adolf Loos said, every material possesses its own language of forms, and none may claim for itself to the forms of another material. So it is about finding an architecture that emerges from the material. One more way to say what tectonics is about uses the example of the brick. This is from Louis Kahn. He used this in his teaching. If you think of brick, you say to brick, "What do you want, brick?" And brick says to you, "I like an arc." And if you say to brick, "Look, arches are expensive, and I can use a concrete lintel over you. What do you think of that, brick?" Brick says, "I like an arch." The point being here that when brick is a material that doesn't have good tensile strength properties, you cannot make a straight lintel when using bricks. You have to make an arch. So arches are what is natural to bricks, and we have to find a way how to build naturally from reclaimed timber if we want to do that. Engineers have studied the properties of reclaimed timber, and they have actually found that in some aspects, aged timber is better than new timber. This is something that architects sort of know. But also there are some properties where the aged timber is inferior to new timber, and these just have to be taken into account when buildings are designed or structures are designed. In brief, we could say that reclaimed timber is harder but more brittle than new timber, which you might have experience of in case you have ever deconstructed very old structures. Very hard, but can be quite brittle. Reclaimed timber is also short. Daishi's study showed us that, but even if we use the best deconstruction methods, we still might have some damage in the wood that has to be cut out. And even if the nails are not too badly bent and you're able to deconstruct the piece, you might have these holes which might be unacceptable for you, so what do? You cut it, and it's shorter than it used to be. You also find these notches of different kinds, like here. So in this log you have a reduced cross-section in comparison to virgin timber. And of course, in many cases you can find that your timber components already have some kind of surface treatment. There is a paint, there is a color that exists. And the pieces and bits that you can recover are very varied. They are not standardized. And this is what you have to deal with if you want to design out of reclaimed timber. So we made a little experiment with students some years back. We have this, or had this course, it's been discontinued, but we had it, Finnish wood architecture at Tampere University of Technology, nowadays known as Tampere University. And this was a part of a project of ours, reuse, repetitive utilization of structural elements. I gave the students the task to design out of reclaimed components. So I had 36 students, and they were divided into two groups. Half of them were designing an allotment garden cottage. So that was supposed to be like a product type of building, not a unique building, but something that can be repeated. And the other half was designing a cafe pavilion, which was more of a unique case, only to be constructed once. So in terms of research, this can be considered a design simulation. So the students, they simulated design by doing this exercise. And then afterwards, I made a qualitative analysis of the graphical material and also the essays that the students produced. And the results of this study have been published. This is openly available, so if you become very interested, you can find it online. The allotment garden cottage, this is what it is if somebody is not familiar with the term. A small cottage not intended for permanent habitation. And the students were to use for these projects any kinds of materials that you can procure from these typical buildings that are demolished. Sawn timber, logs, windows, doors, different kinds of trims and boards. For the cafe pavilion, which was to be located in the Pispala neighborhood, the students could also use glued laminated timber from this storage hall. So these large-scale components. It's since been demolished, it no longer exists. They could choose what materials they would like to use. And out of their projects, I was able to distill these 10 principles for reuse design. Divide the spatial program into smaller units, divide elements into smaller units, avoid equal spans and dimensions, distribute functions for different members, use efficient forms for long spans from short pieces, define ranges instead of fixed properties, rotate and repurpose, select the application according to the properties, combine creatively, and finally let the patina speak. I will show you some examples of these. And on each slide you can actually find a quote from one of the students from their essays as to what they were thinking when they were making the project. The first principle being dividing the spatial program into smaller units, and that is simply because, like you just heard, the reclaimed timber is short. So if you design a very large hall, it might be quite difficult to find any spans to actually create that space. So if it is possible from the start to think about the spatial division so that you have smaller rooms, that could enhance reusing timber, like Paula Tiainen has done in this cafe pavilion. It's not necessary to actually separate the rooms physically like has happened here, but just to have smaller units instead of very large ones. Dividing elements into smaller units is also due to the short nature of the material. And it's shown here with the help of the roof shape. So we start here, if this is the original design that you would like to have, you need quite long joists to overcome this span. And if you change the roof shape, each time the necessary length of joists gets shorter. So by making a smart selection of the shape, you can enhance the possibilities to reuse. And it might seem like, well, I don't want to give my creative freedom away. But that's not how the students actually felt. Like Paul writes here, that reuse gives an impression of moderation, of necessity, and engaged with the design with efficiency. So they didn't actually feel like it was limiting them, but challenging them more than normal design. Well, like we saw in the beginning, we can have very different kinds of lengths in the reclaimed material. Therefore, it's advantageous if you can actually avoid equal spans and dimensions, and this way enable the reuse of different lengths. In Razvan's design, he has this propeller-like roof shape, which would actually be quite tricky to construct. But you can use the same idea with more conservative roof shapes, like happens here. So here you have equal spans, and with each step you actually have more different spans. The fourth principle is about distributing functions for different members of the structure. The dimensions of the structures have been getting larger in time, but that is not only because of, let's say, loads. In the older stock of wooden buildings, you typically can only find 2x4s. And a 2x4 is perfectly fine for the loads of a normal one-family house. It still is. The reason that we normally use in these structures, we don't use 2x4s anymore, we use 2x6 or 2x8. The reason is the increased amount of insulation. But in order to create that space for insulation, we can also use another 2x2 or another 2x4. It's not necessary to increase the dimensions of the load-bearing component to do this. So this would be one way to increase reusable wood. Karian wrote that being used to think that everything is available can cause a gap between the architectural concept and the salvaged components. The fifth principle is about using efficient forms for long spans from short pieces. My examples this time are not from the student projects, but rather from realized projects. So because the timber is short, if we can create new kinds of structures that can utilize this low-quality short wood, we can create some very interesting architectural ensembles like this one from Kogakin University. This is not actually reclaimed wood, but it is wood that is of low quality and that is short, so that's sort of an equivalent. Another example is a historic one from Antoni Gaudi, and these are sort of the early engineered wood structures which used these short pieces of wood which were mechanically connected. It's actually put together from quite short pieces. And something like this could act as an inspiration for structures today. So when using the reclaimed wood, you have to be sort of tolerant towards the material, and you have to maybe give away some of your control to the material in a way. One of the principles is defining ranges instead of fixed properties. And in this example, you can actually see it being used in two ways. First of all, you have these varying lengths. So the student, Simon, has divided the facade into these fields, which are of different length. And secondly, as you can see, they have a slightly different hue. So they are taking advantage of materials that originate from different sources, and they keep the surface finishing and just reuse as it is. Marta said that it was clear from the beginning that some flexibility should be maintained regarding the appearance and availability of the material. And this is exactly what it is. The seventh principle is about rotating and repurposing. This is actually the only example that not the only one, but one of the few ones, that is the cafe pavilion, like you can see in Pispala. And here you have the glued laminated beams being used as a portal. So you have to be creative about the material. If it's a beam, you can still think what else it could be. The beam maybe could also be a column if the loads are much smaller. And Valentin said that what first was an obligation became an aid and an inspiration. That is maybe an example of how the students felt in the beginning and then in the end of the project. Well, whenever you use any construction material, you should always select the application according to the properties. The point here is that a lot of the reclaimed timber is of very short nature and very low quality. So it's possible you can't always use it for any load-bearing purpose. But maybe there are other cladding purposes which can easily absorb these shorter, more varied materials. Here, in the interior cladding, the students have used it. And it has resulted in this very maybe collage or bricolage-like appearance. Not very conventional. But on the other hand, you can find these kinds of laminates used in the floors or in restaurant tables, which are just images of reused wood. You could actually use real reused wood for that purpose if you like the appearance. Paula wrote that it is up to us architects to make use of the advantages of reused materials and to make sure our designs allow materials of any origin to be used. This is also connected to combining the materials creatively. In this case, Ina has combined materials from different sources, but she has arranged them in these fields, which gives a much more organized appearance than the previous one. Erlend wrote that a limited supply enhances creativity. If an architect would have all the materials in the world, the result would be less exciting because one tends to reach for standardized solutions. And finally, you should let the patina speak. So in Paula's project, this is actually the same as in the first principle, the cafe with the multiple rooms. She has used this very modern form giving, but this grey boarding from a barn to make a contrast between the modern and the material. I believe that sustainability can only be gained when the building conveys the message of reuse to its users. And the patina is the medium that the material connects with its user. So these have been the 10 principles of reuse design that could be distilled from the student projects. And to continue a little bit about the last one, the patina, I would like to talk to you also about spolia in contemporary timber architecture. Is spolia a familiar term to you? You can raise your hand if it is. To some, yes. So traditionally, spolia means architectural reuse of stone pieces and statues from the Greco-Roman antiquity during the Middle Ages. Together with my colleague Ida Kalakoski, we have made a new definition for spolia, and that is that a spolia is reuse of building components of any material that enunciates experiential values such as historicity or authenticity. So this is what it is traditionally. This is maybe one of the best known examples, Casa dei Crescenzi in Rome. But we propose that spolia can also be this. This is a boathouse by Tuintegnerstue from Norway, where the material from a previous boathouse on this very same location has been reused in this new boathouse/summer cottage. And we propose that in order to be spolia, the reuse has to fulfill 5 requirements. Firstly, it has to be based on genuinely old material. So any new material made look old will not do. Secondly, the source is important. the material must have its origins in an architectural composition that has since been destroyed, lost, or transformed. Thirdly, the material must have a structural function in the new architectural ensemble. And with structural function, we don't mean just load-bearing functions. The structural function can also be a cladding, but something that the building wouldn't do without. So if the material would be removed, something else would have to be placed there. Fourthly, in order to be spolia, the reused material needs to be visible for the users to experience. And fifthly, the historical time layers need to be observable so that you don't mistake the building for a genuinely old building, but you realize that it's a new building which has some material from the past which conveys its values to the present time. As here are also some further Nordic examples of the kind of architecture where the material conveys some message from the past for the users to interpret in the present. Interestingly, all of them are actually made of logs, so it seems like logs have this quality of transferring some of these values to the present. And maybe it's a challenge then for us how sawn timber and engineered timber products could do this in the future. To conclude, I want to say a few words about what you've heard from me today. So I'd like to acknowledge that tectonic wood architecture from reclaimed components will not solve the large-scale environmental problems of our time, but I still think that awareness on tectonics and spolia may enrich and inform at least some of the architecture that we create today. And at the same time, I think we should acknowledge that transitioning into circular economy in the construction sector may mean that we do have to change some fundamental issues in the way we build today. So maybe small-scale projects may act as inspiration and catalysts towards a greater change. After all, a journey of 1,000 miles begins with a single step. Thank you.
Thanks, Satu. I totally agree with that. We, of course, always are claimed about working in the small scale, but I think that's very good scale to test things. By the way, about log and solid timber, one of my master thesis students kind of donated or had a few modular buildings from '69, which was in quite poor condition, used as a sauna. And she took the components to her summer place on an island on a nice cliff by the sea. But unfortunately, the summer winds flushed the whole package to the sea, and little by little they started to collect them back after maybe several weeks floating on the sea. And the glulam columns and all the solid wood components were in perfect condition. Of course, all the kind of plywoods and such things were totally demolished. So solid timber is amazingly durable material. So that's totally true. So now it's time for the questions.